Yeah, welcome everybody. We will be talking about forecasting and operation in today's video. Nothing but the forecasting part is what we will be talking. So how do we forecast, or should I say predict future? And that too in a business operation. Now business operation is what we are trying to forecast: number of sales, number of acquisitions, yeah, number of productions, units, and so on and so forth. This helps in allocating our budgets. This helps in planning our manpower, and so on and so forth. So forecasting in operation is of vital importance. The agenda for the day is identify principles of forecasting. Definitely, yes, we will talk about it. The various steps in the forecasting process. Thereafter, we'll move into identifying the types of forecasting methods and their characteristics. Describe time series and causal method, as in the reason behind why a certain thing has been expected to happen. So these things are to be discussed in this presentation. I'm sure this presentation is going to be an enriching one for all of you uh, who are watching this particular videos. Apart from it, we'll take about forecasting of data with different pattern, and how do we come and arrive into a certain situation. Now this can be based on level, on a trend, on seasonality, or perhaps it can be cyclical. So we will try to generate forecast of data and the reason behind it, and there might be various applications to it. Describe causal model in utilizing linear regression is what we will talk about it. Yes, we are going to talk about the accuracy of forecast. Remember, not all forecasters or not all predictions comes true. There might be a little bit of a variations here and there. So let us understand with a plus minus 5%, 2%, 3% variation, how to compute forecast accuracy thereby. So explaining how forecasting models should be selected as in this particular presentation. So let us proceed with the principles of forecasting. Yes, many type of forecasting models exist, and in fact, I have seen a lot of models coming up, and right from simple forecasting method, things are getting complicated of late, and it has become very complex because nowadays a lot of parameters, uh, lot of issues or lot of factors are taken into consideration, and because of this variation, because of this huge number of parameters, there it becomes very complex operation. So we need to understand, but we should always assume, and it is a fundamental thing, that forecast, we are not essentially gods, right? We are all engineers, perhaps we are all managers, perhaps we, at the end of the day, we are all human beings. So forecasting is really perfect. I said there might be an error of plus minus 2%, 3%, 5%, which is acceptable with everybody, all statutory body. This is acceptable, this amount of variation plus minus 5%. Forecasts are more accurate for group data than for an individual events. Obviously, yes, individual events we cannot predict, probably, but in a group there is a characteristic, there's a norm, there's a parameter that has been set around it. So a group data are, the volume of the data will enable us the forecasting to be much more precise or probably correct. Forecasting are more accurate on a shorter term, but they vary and they lose their accuracy when we are predicting on a long time period, as I say. The types of forecast methods. Now, how do we go around with the types of forecasting methods? Decide what you need to be forecasting, levels of details to be understood time and again, where we are looking forward to the details, the unit of analysis, the time horizon, whether it's a short-term basis or a long-term basis, evaluate and analyze the appropriate data that has been present, select and cost the select and test the forecasting data. Now, this can be cost, it can be ease of accuracies, probably understanding of the factors. So we need to understand different data set that we are looking into it. What are the data? Are they relevant or not? Is it available or not? At the same time, when we are procuring data, we need to understand whether procurement of data is easy, is it costly affair, is it accurate enough? Generate the forecast thereby, and probably monitor your forecast with the passage of time, and probably you should be able to incorporate the different variation that has been there with, or with the changing environment, business environment I'm talking about. With the business changing environment, you need to manipulate your forecast a little bit here and there, and that is what is the requirement of the day. So forecasting methods are classified into two groups. They are the quantitative methods and the quantitative method, the qualitative method and the quantitative methods. Let's say, let us discuss it on the basis of characteristics, strength, and weaknesses. As far as characteristics are concerned, if we look into it, qualitative data are always based on human judgment. But on the other hand, quantitative data are based on mathematics, based on the natures of the thing. So human judgments is all subjective, all non-mathematical, which is not the case with quantitative. That is the reason which we go around it. Then comes the strength of the data. This is very important. Can incorporate the latest changes as far as quality is concerned. Latest changes. There is a change in the rules and regulation. Probably the federal government changes certain taxation rules for a particular industry. Now you should incorporate in your forecasting model and come up with an new changes or new forecast that comes around it, the new data that comes around it, the new output that comes around it. So it can be incorporated. It's based on a human judgment, and things have changed. I'm talking about the business environment. Talk about the quantitative method. It is consistent and objective. There are no elements of emotions coming in. It can be able to describe the information and data and one at a time. Then comes the weaknesses altogether. What are the weaknesses of qualitative data? Believe me or not, since it is human oriented, because it is based on the judgment, because it incorporates the latest data with the changing environment, it can get biased. One of the basic demerits of qualitative data might be it can be biased, and the accuracy depends on the predictability or the quality of the human being or the human or the person who is predicting it. He or she might be biased towards one or the other affairs. On the other hand, quantitative data are not available easily, as they are available, as good data are based, are difficult to find out, and accurate data is much more difficult to predict altogether. But then that is the requirement of a quantitative data. Quantitative data might be very cost intensive, might be very labor intensive, might be very time intensive. So you need to go around it. So we have those differences as far as characteristics, strength, and weaknesses are concerned about everything that we comes around it, right? I hope I'm clear with all of it. I will talk about them one by one. And in the qualitative methods, it is always said as a judgment methods. On the quantitative method, it will be always said as a mathematical modeling. We will talk about it. So forecasting generated subjectively by the forecasters and educated guess thereby. This is what we are looking into it. Forecasting generates through mathematical modeling, as the case might be, everything. So we are talking around only about the forecasting methods out here. Qualitative methods, on the other hand, if we look into it, I am having the same parameters of characteristics, strength, and weaknesses carried about. We look into the executive opinion. When it comes up upon to the executive opinion, a group of managers or group of people come up to a decision, and that is what they come up with a forecasting method. So the strength will be, it might be their understanding, depending on the quality of the group, individual members of the group, it can give a better strength of understanding, probably for a new product development and so on and so forth. Weaknesses, even in a group, there are few person who might dominate and they might take sway over the group opinion altogether. In terms of market research, what happens is, in the characteristic part, we utilize a lot of surveys, lot of interviews to understand what the customer is looking for it. So the strength out here is to determine the customer preferences, definitely yes. But then probably if you are looking at a customer preferences, you might do away with your cost influences. You might be including into a high cost affair. So how do we go around it? One. Next is, it is difficult to come up with a or design a particular questionnaire that is keen and tuned to every one of them, what we are looking out here. Then comes the Delphi methods. Delphi methods seeks to establish a consensus among the group of experts that we are talking around here. Believe me, we are talking about a group of people who come and arrive to our decisions. In terms of strength, excellent for forecasting long-term products, demand technologies, and probably this is very good. Delphi method is very good for a longish prediction, right? But then the weakness is, it consumes a lot of time. As it involves Everybody wants to have their say into it. Delphi methods is all about a longish group interaction with an interruptions every now and then, and it can be the longest group interactions can be on an individual basis also. It can be a hub and spoke method as we go around it. This is something which is an hub and spoke method that comes around it. We need to understand why we are talking about it. So time series model, definitely yes. We'll talk about the quantitative methods. Assume information generate a forecast over a period of time. We collect data for this year, previous quarter, this year, and probably we are trying to predict the next quarters or next year's sales, revenue, production, you name it, and we can have it. So it's a time series method. We are extrapolating the time period for the last 5 years data, and then probably we're trying to predict for the next year's data. So assume the future will follow the same pattern as the past, as the case might be. Then comes the causal models or the associative models. As we are looking into it, we are talking about exploring the cause and effect relationship using a leading indicators over a period of time to predict the future. Now, why do we call about here? It is all about housing starts and appliances, right? If we cannot go about it, we will talk as on when on basis. Time series model, we'll talk about the time series model. I suppose we will talk about the forecasting pattern. Now we are looking at the historic pattern and the random variation that comes around it. Now what is the random variation? Probably again there might be a hike in the demand of the product. Perhaps there might be a change in the regulations of the government, probably, perhaps. So what is the historical data and what are the new elements that has been introduced, and probably we can incorporate it to predict the futures thereby. So historic patterns to be forecast is on a long-term average, as in average of last 5 years, last 2 years, last 3 quarters, and so on and so forth. So data fluctuate constantly, and you need to go around it. So we will be talking about 5 years quarters. What were the data around it? Average quarters. We can always have quarter 1 of each year and then average it out. We can have data of quarters of each alternative quarters and then can average it out. So this gives us a long-term average. Now, then comes a trend. A trend is basically which tells you whether it is moving in one direction or not. Trend is always upward or downward, as the case might be. The data will be exhibiting it. Seasonality is in a pattern that regularly repeat itself every season. As winter comes after the rainy season, the rainy season comes after the summer season, and so on and so forth. It is seasonality that repeats itself at a constant length, and cyclical is patterns which has economic fluctuation, if I'm not clear it. So that is what cyclical models would always say around it. And then there is something called random variation, which probably cannot be predicted. It depends, and we are not even sure about it. Why a certain things happen? Probably, if you see a certain movie might come up into a blockbuster affairs in the box office, despite the fact that it might not entail big stars, despite the fact it might not entail big technological gigs around it, but the simplicity of the story might take the film into the higher heights. So that is what a random variation can be predicted altogether. So I am showing a pictographical representation of a level where if you look into it, it's more or less the same thing that goes around it at the same strength. Now this is where it is a trending pattern. If you look at an overall part, this is what the trend pattern will tell it to you on the upper hand. On the other hand, if you look into it in this particular pattern, it is cyclical. If you go it, this is the way it comes around it as a reflection, if you look into it. But this is what seasonal would be looking into it. But look what is happening with cyclical. There is a definite downturn, there is upturn, and probably there will be a downturn. That is not the case with seasonal pattern as we have shown it to you. So please understand the pictographical representation of whatever I have discussed it around it. Now let me come up with the time series model one by one. If you look, I have already given you the formulas on the particular slide, and you are able to look around it. So, one is a NIF, a basic forecasting, where we are actually having forecasting about yesterday's day or yesterday's week's performance, and we try to forecast about the next week performance with a little bit of an anomaly that we go around it. The forecast is more or less equal to the actual observed during the last period, and a good level pattern, as they say. Then we have the simple mean. Simple vein is where the time series, please understand, this is t plus 1 is the predicted predicted value of all the things that comes around it. The simple mean is average of all available data. Let's 5 years data has been averaged out, or let's say one particular quarters of each 5 years data have been averaged out, or let's say every alternative quarters of last 5 years have averaged out. So we have got three averages, right? The 5 years, the alternatives, and so on and so forth. So this is what we are talking about, the simple mean thing. And then we'll introduce a term called simple moving average, or should I say a moving average, which is again is a summation of the period divided by the number of period that we are looking into it. So average value over a set period, let's say the last four weeks example is new forecast drops at the oldest data point and adds to a new observation, thereby more responsive to a trend but lags behind actual value, right? So what we are looking into it, as the case might be, saying around. So time series model, if we continue with it, we can have a weighted average modules around, wherein for every weight which needs to be understood, the accuracy or the parameters or the importance, we need to give a weight to it. Let's say the sale of an umbrella might grow up in the rainy season. Why? So the rainy season will have 50% weightage. Then probably the affordability of the umbrella might have 20% weightage. Then probably 20% of weightage can be given to the lifestyle of the umbrella, and last 10% of the umbrella would be to the availability of umbrella in the various retail shops. So what I'm trying to give it to you, all weightage 50, 20, 20 and 10. So odds add up to 100% or 1. So I just give it to the weightage that needs to be added to 1 or 100% as the case might be. As we have told you about the umbrella things, so allows emphasizing over a period over others, indicate more weightage, that might be recent basis, differs from a simple moving average, but weighing all periods equally, more responsive to the trend as the case might be. That is what has been given out here. Let us understand the exponential smoothing effect. With this passage, most frequently used time series method. Remember, we are talking about the alphas that we are looking at, and this is the smoothing effort. Why smoothing? Because I say that we have made a sale of 10 units in the previous week, right? In the next week, we might be having a sale of 15 units. That's 50% chance. Why? Probably it might be a salary week, it might be bonuses that might be available at the hand of the people. So what are we talking? We are talking about the disposal income. The alpha depicts that exponential smoothing, and this is a hike out there. Usually it might not be hike, you can be predict it can go less also. We have sold 10 units, we might be looking at 7 units sale in the next quarter or something like that. We got to go around it. So not just three pieces of data to start with. What we are looking out here, it's a last period that comes around it, the alpha comes around here. So last period forecast, the actual forecast, and then we have a smoothing alpha between 0 and 1, depending upon whether the rainy was there cloud formation, was rain actually happening, was it flood like situation, what we are looking at. And that is what the smoothing coefficient will be always be talking about it. If no last period forecast is available, average the last few period, or use a naive method to go around it. So example alpha, example being very high on a 0.7 or 0.8%, that means it is bound to rain, and it is in a rain oriented places where it rains almost 6 months a year. Probably it's a very mountainous zone and things like that. So may place too much of an effort to the last period random effort. So that means umbrella might be a factual habit of all the people or the people inhabiting that place, where it rains approximately half of the year. So linear trend line, a time series technique that uses computes a forecast with a trend by drawing a straight line. Now this is what we are talking about it. The drawing a straight line is something which we goes around here, where y is the forecast period. This is why we are looking into it. Absolutely, this is the why. The period is x, is depicted on x as we pass on the time, and the value of y is 0. At this point it is 0, right? At the origin point of it, and b is the slope, and this b is the slope that we are talking around it. So as we pass on with the time, how we go around, well, how does the linear trend goes around it altogether. So forecasting seasonality, how do we go around it? It might be calculated on average demand per season, or probably average quarterly, or average biannually, as the case might be. Calculate seasonal index of each season of the each year, divide the actual demand of each season by average demand per season for that year, and so on and so forth. Average the indexes by the season, as the case might be. If you are looking out here, take an average of a spring index, let's say, or the summer index, or the rainy index, or let's the autumn index, or the winter index, and probably if you see your how in particular season, how was your business been impacted. If you can draw in a relationship, nothing like it. You are able to do it everything now and then all together. So we will be talking about the forecasting demands for the next year. Divide the number of season, use regular forecasting method, and probably divide by 4 the average quarterly demand, as the case might be, and then probably we extrapolate it for the next year's seasonal demand of each average season index. So we have something for summer season, autumn season, rainy season, winter season, spring season, and so on and so forth. So result is forecasted of the demand for each season of the next year, as the case might be. Very easy to understand. I am sure most of you have got the point correctly. Now we talk about the cause and effect method, or the causal model that we are talking about here. Here it is often the lead indicators which tells to how to predict changes or what is going to happen in future. Let's say the demand for umbrella, let's say a demand for accommodation, let's say a demand for jobs, or let's say a demand for cement industry. If there is some civil industry is at the boom. Causal models establishes a cause and effect relationship between independent and dependent variable, as the case method tells you. A common tool of causal method is linear regression. I have already said it to you, the linear regression, which is basically the previous slide that I've given you the slope around it. We have the x-axis where it is the number of years. If it is the number of years we are talking about here, out here, right, and the number of units that we are selling in the y-axis and plotting it out. So when we start a business, there is something, nothing goes around, but when with the passage of time, it can goes out here, and this is what y is all about. It is a plus bx, the number of unit that changes altogether as on when on basis, as the case might be. So a plus bx, that is what we are looking out here. Multiple regression will have different factors that comes around it. It might be for the first year, the first plus and to a multiple factors which goes around it. A lot of regression develops as in a dependent variable and in multiple independent variable that comes around it. Did I say about the sale of an umbrella in a rainy season would be the amount of rain, amount of availability of the umbrella, the branding of the umbrella, the habit of the people, the lifestyle of the people, the pocket pinch that the people are having to purchase an umbrella, maintain an umbrella. So there are a multiple of relationship that comes around it, and based on these things, the sale of the umbrella would be depending upon it. So you need to understand the general formula thereby. Forecasting errors. Now, this is something which you need to understand. We have errors. We cannot be very correct. There is something A for actuals and FT for forecasted. What is forecasted might be 100 units to be sold, and actual was 110. So there might be errors of 10% out there. But actual was 90, it would be an 11% changes in the error. So there is an error which always happen around it. So actual might go. So this in one of the places is my 10% increase, in another thing it might be 11%. You are but just deferring it by 10 units, you are failing by 10 units. So forecast are never perfect. You need to know how much we should rely on a chosen forecasting method thereby. So basically this is the formula of measuring the errors. ET is equal to AT, which is actual, minus forecasted on a basis of time period. T denotes the time period, E denotes the error. Note that over forecast negative errors and under forecast is positive error. So if we have forecasted 100 units and we are selling 110, that would be that will be under forecast, because forecast was 100 and sell was 110, so it's a positive error. But in case if the forecast was 100 but the sale was actual was 90, so it will be a negative error in that scenario. Similarly, forecasting about over a period of time, we are talking about MAD. If you look into its mean absolute division values, it's a mean of mean that needs to be taken care of for the forecasted mean, the actual mean divided by the period that we have gone around it. That is the mean actual divisions. Again, 90 actuals or 110 actuals, forecasted was 100, as in the case might be. Similarly, cumulative forecast area, which is summation of actual forecast minus summation of the forecast that we have done it, the actual things that we have received and the forecast that we have done it. So that is what we need to go around it over a period of time. Mean square method is MSE, which is actual sales or actual production minus forecasted sale or forecasted production whole square divided by the number of years or the number of time period that we are looking into. N denotes the time period. Tracking signal is similarly would be cumulative forecast divided by mean absolute division, and that is tracking signal whether you are on the right path or not. Measure if your model is working or not. Selecting the right forecasting method, I have set so the amount and the type of available data. Some methods are required for more data than others, probably yes. In fact, I reckon that more the data, the accurate the forecast would be. If you can take maximum data and take in the maximum factors that can be incorporated, they are your forecasting becomes much more reliable. So degree of accuracy required is increasing accuracy means more data, which I've already stated. So length of forecast, different models depends from 3 years to probably 120 months, 3 months to 120 months as the case might be. So from 1 quarters to 10 years we are looking into it. Presence of data pattern lagging will occur when forecasting model means a level pattern has been applied with a trend as the case might be. This is what we are looking forward to it. There are a lot of software, please believe me or not, this is something which you can always link into it. The most popular software is the Microsoft Excel as such, or Quadrapo and Lotus 123. Lotus 123 has been incorporated in Excel of late, but it was the fundamental basis of Excel. Then we have a lot of SPSS, SAS. Now, SPSS is software statistical packages for social sciences. SAS stands for software as a service. We have NCSS, Minitab, MATLAB. If you go around it, forecasting plus statistical and graphical. Special forecasting packages include Forecast Master, Forecast Pro. You can have it, and I'm just giving it to the audience so that audience can always Google it and download it for themselves. Apart from it, there are host number of forecasting software which is actually available. Believe me or not, for every individual industry, softwares are different because parameters are different, for audience is different, the clienteles are different, the methodology is different of collecting the data, so on. So you should be very sensitive when you are choosing a software for your utilization. I would nevertheless try to give you a guideline for selecting a software. You need to understand what are you looking for, and if what you are looking for is available within the software or not. What platform is available for, how easy for you to pick up the tricks and implement it. These are the questions that you need to keep on asking when selecting a software. Then probably can you incorporate or tweak the software to your benefit, your requirement. Can we tweak it down? Do we require to be interactive or repetitive forecasting? Do you have a large set of data as the case might be? Is there a local support training available? You should always have a help desk, access to the help desk of the software that needs to be taken care of. Does the package give the right answers, and so on and so forth. So other forecasting methods are focus forecasting developed by Bernie Smith, relies on the use of simple rules as in the rain and the umbrella probably, but why not the sun and the umbrella? If it is very sunny, if it is very hot, very humid, you need to put an umbrella while walking on the beach, on the road, and so on and so forth. Test rules on past data and evaluate how they perform. And we can have a combination of forecasting. This improves our accuracy. If we can have more than 2 3 forecasting method and probably arrive into more or less similar solutions, similar forecasting data, it tells us the accuracy and reliability. It increases the reliability by leaps and bounds. Collaborative planning, forecasting, and replenishment, or what we call it as CPFR, we need to understand the collaborative relationship between buyers and sellers. Can we have a joint business plan? Can we understand the fact what has been required by the other party? Similarly, how can we replenish it? How can we fulfill the best? in the process we are creating a win-win situation, a win-win sales forecast as the case might be, because then we can identify exception in sales forecast, resolve, collaborate on the exception item, create orders forecast as on when on basis. Definitely, yes, identify exception for order forecast is thereby resolve, collaborate an exception item. Now, there might be a requirement of our customers probably where you have to tweak their orders to their requirement. If we can understand, come up with it, we will be talking every now and then as on when on basis. So we need to go around it, right? Now, let us understand forecasting of operation management, how it all fit together. Forecast impact not only other business function, but also operation decision. Operation managers make forecast very difficult, such as the expected demand of the company product. These forecasts are then used to determine the product design that are expected to sell, the quantity of product to produce, the amount of needed supplies, the amount of needed materials that we are looking for it. So did I say if we have a definite forecasting method, I can arrange for my revenues, I can arrange for the finances, I can arrange for the raw material, I can arrange for the manpower. We need to come up with a viable product that is acceptable by all the customers, the quantity, the number of quantity to be produced, the amount needed to be produced, and so on and so forth. So also a company uses forecast to determine future space requirement. We are talking about capacity building, we are talking about location needs, we are talking about the number of manpower out here every now and then as on when on basis. Forecasting drives strategic operations decisions such as the choice of competitive priorities, changes in the process, and a large technology purchases. Forecasted decisions serves as the basis for tactical planning, developing worker schedule. Virtually all operation management decisions are based on a forecast of the future as the case might be. We are looking forward to it. We need to understand, if we are bang on with the forecasting, our operation become much more smoother. We can plan everything as far as changes are concerned, technology incorporations are concerned, decisions for tactical planning, everything becomes much more smoother across the organization. It is very critical to come to for the management to arrive to our decisions and probably implement it. So marketing relies on the product demand, probably yes. We are looking at uh, probably the finance as far as the requirement for money, raising of the revenues, cash flow, finances. Information system will be requiring for the databases to be shared. HR requires for the manpower planning, which I have been stating it from the early in the particular presentations. So we require everywhere, and it helps, it augments management for planning, marketing needs, finance needs, information system needs, human resource needs. So in totality, let us come to and summarize what we have discussed. Three basic principles of forecasting. They are very rarely perfect, but are more accurate for group data than individual items, and more accurate on a short-term duration than on a long-term horizon. Similarly, forecasting process involves 5 steps. One, decide what to forecast. Two, evaluate and analyze the appropriate data. Three, select and test model. Four, generate forecast. And the last one is to monitor accuracy as the case might be. Forecasting methods can be classified into two groups, qualitative and quantitative. Qualitative methods are based on subjective opinions of the forecasters. Quantitative methods are based on mathematical modeling as the case might be. So what we are looking out here is what forecasting methods are classified. Two groups, qualitative and quantitative. Something very simple. Qualitatives are emotional oriented, quantitatives are non-emotional oriented. Qualitatives are subjective oriented, quantitatives are mathematical oriented. The time series models are based on assumption that all information needed is contained in the series. As the case might be, we are talking about time series data, which comes up with causal models, variable models forecasted over a period of time in a different environment. There are four patterns altogether. What are they? They are level or horizontally trend. We are talking about seasonality and cycles. Remember this thing. In addition, data involves random variations, probably which keeps on changing over a period of time. So it becomes very difficult. So forecasted can also be on a time series method on the naivety, on a simple mean, simple moving average, weighted moving average, exponential smoothing, and so on and so forth. So we need to understand the level, the horizon, the trend, the seasonality, and cycle. These are four basic pattern of data, and then on the basis of time series, if you're looking into it, it's naive basis, something very which is basic, simple mean, simple moving, weighted moving average, exponential smoothing, and so on and so forth. A simple causal method is a linear progression that comes around it, which is basically a straight line relation between variables which we are forecasting and another variable which are a part of an environment. The correlation is used to measure the strength of the linear relationship between the two variables thereby. We come to the very fag end of the slide where we have spoken about the errors which comes around it, and that is MAD or mean absolute deviation, or MSE as a mean square error, or the tracking signal, which is the division of MSE divided by MAD. As the case might be, there are four factors to consider when selecting a model: amount, type of data available, degree of accuracy required. You know, if the degree is very high, then the amount, the volume of data has to be huge, absolutely huge. Length of the forecast horizon, I believe you can predict it for the next quarter, next year at best, but probably 3 years from now is too far a time. But then people do predict it altogether: 3 years, 5 years, 10 years, and so on and so forth, and the patterns that is present in the data. With this, I come to an end of this presentation. Thank you for watching this video. I'm sure everybody is enlightened with the fact of how forecasting helps in having a smooth operational management of a company. Thank you.